guys, my name is Craig and welcome to Peri Solutions. In today's video, we're going to talk about how we calculate the modulus of a vector, or in other words, the magnitude of a vector. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. Okay, so to start off, we shall define what the magnitude of a vector is. Right. So the magnitude of a vector is simply the length of a line that represents that vector. Right. So we're saying this is the length of a line that represents a vector. And it is denoted by, say for a vector AB, right, we say that the magnitude of this vector, right, is denoted by these bars. Right, so this is also sometimes called the modulus of a vector. Right, so to calculate the magnitude of a vector, we use the Pythagoras theorem. So say we've got this plane, this is the y, this is the x, 0, this is point A, and then this is point B. So for a vector AB, if we need to calculate the magnitude, we're saying that the change in x, this is the change in x, right, and this is the change in y, right. So we know that AB squared is given by x squared plus y squared, which implies that AB would be the square root of x squared plus y squared, like that. So this is how we calculate the modulus of a function. So in short, we can simply say that in 2D, right, the magnitude of a vector AB, or the magnitude of a vector AB, which is xy, right, is given by the square root of x squared plus y squared, right? And in 3D, right, we can say that the modulus of a vector AB, the magnitude of a vector AB, which is xyz, right, is given by AB, then modulus here, square root of x squared plus y squared plus z squared, like this. So this is how we calculate the magnitude of a vector in 2D and in 3D, right? So something else that we should know is how we find the unit vector. So a unit vector, this is simply a vector of magnitude 1, right? So a unit vector, if we now need to calculate a unit vector, let's say we want to find a unit vector in the direction of a vector A, right? We say that A over the magnitude of A. So in other ways, to calculate a unit vector in the direction of a vector, we simply say we divide that vector by its magnitude. So this is how we calculate a unit vector. And if we now need to say we want to multiply a vector by a scalar, we multiply each of the terms inside the brackets. So if we say 2 times vector 2, 3, 5, we say 2 times 2 to get a 4, 2 times 3 to get a 6, and 2 times 5 to get a 10. This is how we multiply by a scalar, right? And a vector that is found as a result by multiplying another vector by a scalar is parallel to that vector, right? It's parallel to the original vector, right? So in this case, we are getting vector 416 as a result of multiplying by a scalar of 2 this vector. So this implies that this vector 416 is parallel to vector 2, 3, 5, right? So parallel vectors are of the same magnitude but different directions. Right? Sorry, parallel vectors are of the same, they can be of the same direction or of opposite directions, right? And as you can see in terms of the magnitude, that this vector is twice this vector, right? So parallel vectors are scalar multiples of one another. Okay, so now would like to attempt those questions. Allow me to use this. Okay, so for number one, I asked to calculate the magnitude of these vectors. So for number 1a, right, we are saying that this is in 3 dimensions. So the magnitude is going to be the square root of 2 squared plus minus 4 squared, then plus 5 squared, like this, which will be equal to square root of 4 plus 16 plus 25, right, which is square root of 45. And of course we can reduce this to say root of 9 times root of 5, which will be 3 root 5. Right, so this for the first one. Then for the second one, that one is in 2D. So I simply say the magnitude shall be the square root of 5 squared plus 3 squared, which is square root of 25 plus 9. This will give us root of 34. And we can just leave it in set form like that. Then for part C, that one is in 3D. So saying square root of 10 squared plus square root of minus 5 squared. So plus square of minus 5, then plus 10 squared. Right, and then these square brackets. And this will give us square root of 100. This will give us root of 100 plus 25 plus 100 in brackets like this, right? This will be root of 225, which is equal to 50. So 15 units will be the magnitude of part C. Then for part D, that one is in 2D. So we're simply saying that for part D, the magnitude shall be square root of minus 3 squared plus minus 9 squared. Then we find the square root of that. This will be the root of 9 plus 81, which is root of 90. And we can reduce this to say root 9 times root 10, which is 3 root 10. So in set form, we've got 3 root 10 is the final answer. And now we shall move on to number 2. So I shall erase this. Right. Okay, so now moving on to number 2. Number 2 says find a unit vector in the direction of vector 2i minus 3j plus k. So we say to find a unit vector, we simply divide that vector by its magnitude. So we're saying that for 2a, we've got vector 2i minus 3j plus k over the square root of 2 squared plus minus 3 squared plus 1 squared. Those being square brackets. And this will give us 2i minus 3j plus k over root of 4 plus 9 plus 1, which is 2i minus 3j plus k over root of 14. Like this. So we can just write it as 1 over root 14 multiplied by 2i minus 3j plus k. And we can decide to rationalize this, right? Which will be, if we rationalize it, multiply, right? This will be root 14 over 14, right? 2i minus 3j plus k. So this will be the final answer. Then for part B, 2b, we're saying that minus 1, 2, 3, right, over the square root of minus 1 squared, which is 1, plus 2 squared, which is 4, plus 3 squared, which is 9. right? And as well, this will give us root of 14. So this is minus 1, 2, 3 over root of 14, which we can decide to write as 40, root 14 over 14 minus 1, 2, 3. Right. So this is the unit vector for in the direction of this vector. So now we shall move on to number 3. Right. So for number 3, we're asked to find the values of C for which the following vectors are parallel. Right. So for the first one, so here the basic idea that we have to implement is that we have to factor out some scalars in such a way that what remains for these vectors is the same. Right. So for the first one, we've got minus 15, 36, and 21 being equal to minus 20, 48, and C. So here if we factor out 3, right, let's say we factor out 3 here, we get minus 5, 12, and 7. Then this side here we factor out, let's factor out 4. We'll get minus 5, 12, and we'll get what here? We'll get C over 4. Like that. Right, so 7 should be equal to C over 4, which implies that C is equal to 28. In such a way that here, if this is 28, 4 into 28 will give us a 7. Sorry, 4 into 28, yes, it will give us a 7. And that 7 will be equal to that 7. So C is equal to 28. Then for part B, we've got 1i minus 2j plus 4k and 0.5i minus cj plus 2k. So here if you factor out 2, right, let's factor out 2 for that vector, we'll get a 0.5i minus j then plus 2k. And this one is 0.5i minus cj plus 2k. So c should be equal to 1. Right. That's pretty straightforward. C is equal to 1 in that situation. Then for part C, we've got 2t minus 4t 5t being equal to 3t 6t ct. Right. So what do you have to do here? Okay, if we factor out 2 from here, right, we get a t minus 2t and then 5. Okay, in actual fact, okay, let's just go with that. So we factor out 2 here, right, and then this side if you factor out 3, right, if you factor out 3, we'll get a t, right, then 2t, and then c over 3t, like this. But we need this to be equal to that. But suppose this negative is not here, right? Such that it's like this, right? So this should be equal to that, which implies that 5 over 2 should be equal to c over 3. So 5 over 2 should be equal to c over 3. Then c would be equal to 15 over 2, right? Which is 7.5. So this will be the value of c for part C. And then now moving on to number 4. Right, now for number 4, we've got the points A, B, C, and D form a parallelogram. So we know that a parallelogram is of this shape, right? Something like this. So if we say we've got our A, B, C, then D, you know that for a parallelogram, opposite sides are what? They are parallel equal. So we say if we have AD, then BC. So we are supposed to find the coordinates of C, But we know that AB and DC are parallel and equal. So if we could find AB, vector AB is simply subtracting the coordinates of B from A, subtracting the coordinates of A from B, actually. Right? We're saying that 1 minus 1, we get a 1 plus 1, which is 2. And then minus 2 minus 0, we get a minus 2. And 2 minus 3, we get a minus 1. So this is AB. But we see that AB and DC are equal. So DC is given by subtracting the coordinates of D from C. So we're saying that minus 2 minus x, right? Minus 2 minus x, then 4 minus y, and sorry, this is supposed to be DC. Oh, this is DC, and we said for DC, we're saying that the coordinates of C minus the coordinates of D. So x minus 2, that's x plus 2, and then y minus 4, and z minus 5. This is DC. But we say DC is equal to AB. So this is equal to 2 minus 1, which implies that x plus 2 is equal to 2, and x will be equal to 0. Then y minus 4 is equal to minus 2, which implies that y is equal to 2. And then z minus 5 is equal to minus 1, which implies that z is equal to 4. So x is equal to 0, y is equal to 2, z is equal to 4. Such that the coordinates of C would be 0, 2, and 4. Like this. Then part B says find the unit vector in the direction of AD. So in the direction of AD, we're simply finding the vector AD first. Right, so AD is equal to coordinates of D minus A, minus 2 minus 1, that's minus 2 plus 1, which gives us minus 1. And then 4 minus 0, that's a 4. And 5 minus 3 is 2. Right, so we want to find the unit vector in the direction of that vector. Minus 1, 4, 2. So we're simply going to say minus 1, 4, 2 over square root of 1 squared, which is 1, plus 4 squared, which is 16, plus 2 squared, which is 4. Like this, which is minus 1, 4, 2 over root of 21. And we know we can rewrite this as root 21 over 21 times minus 1, 4, 2. So this is the unit vector in the direction of AD. Okay, so this was simply looking at how we find the magnitude of a vector and how we simply apply the formula of finding the magnitude of a vector, and as well finding the unit vector in the direction of a specific vector. And as well, we looked at parallel vectors, and we mentioned that parallel vectors, they are scalar multiples of one another. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.